let's work this closed pipe problem. A closed pipe resonates with a 320 hertz tuning fork. What is the wavelength of the sound created? Calculate the 3 shortest wavelengths of pipe that will resonate with this tuning fork. And one thing I didn't write down is you can assume that the speed of sound is 343 meters per second. That's what I'm going to use, plus or minus a couple meters per second. That's a good value for it. Well, so here's what's given. So we've got a closed pipe, and we got a tuning fork that's vibrating. It's up and down, and the frequency of the tuning fork is 320 hertz. We want to know what is the wavelength of the sound. And B, oh, please, no more sneezing while I'm recording. All right, calculate the 3 shortest wavelengths, so L1, L2, and L3. That's what I'm trying to find for this closed pipe. And so let's solve it. So for part A, velocity equals frequency times wavelength. So for sound, or any kind of wave. And so we can solve for the wavelength equals the velocity divided by the frequency. This is 343 meters per second. And the frequency is given to be 320 hertz. Now hertz is waves per second. And I like to show the units on here, waves per second, because you can see that the per seconds cancel out, and you're left with meters per wave. Now a wave, the counting number of waves or whatever, that's not a dimension. It's not one of our basic fundamental units or anything, but it's an idea we can think about. And so what do you get when you divide 343 by 320? I think it's 1.07?
Yep.
Meters per wave. We'll just leave it as meters. Yeah. Now for part B, well, we have an equation that says that L1 is equal to, well, what is it? It's 2n minus 1. We'll put it L to the n. Times what? Times the wavelength over 4. Now that's one version of it, and we can use this since we now have the wavelength. You can also say that it's 2n minus 1 over 4. And then you can put v over f. So if you're given the frequency, you have to take the velocity of the wave divided by the frequency. But notice the velocity divided by frequency is wavelength. So this is just a different version of this equation that you can use. Well, we want L1, so we just put a 1 in there. 2 times 1 is 2, minus 1 is 1. So the first wavelength is just the first length that resonates is just the wavelength divided by 4. So what is L1 equal to? What is 1.07 divided by 4? 0.27? Is it 0.27? Now L2. Well, what do we substitute in for n here? The 2. So it's 2 times 2 minus 1 times the wavelength over 4. Well, what's 2 times 2? 4 minus 1 is 3. Remember, another way of remembering it, it's the odd multiples of the first length that will resonate. So you'll get one that is 3 times as long. So that's 3/4 of the wavelength. Let me just plug the value in here. Of 1.07 meters. And so L2 is equal to, what is that, about 0.7 something? 0.80? Is it 0.8025? Okay.
0.8025.
0.80, we'll just call it 0.80. Those 2 significant figures. Okay, and then L3, gotta fit it over here. Well, N is now 3, so that's 2 times 3 minus 1 times the wavelength over 4. So that's 2 times 3 is 6 minus 1 is 5. So 5/4 times the wavelength. And so L3 is equal to what? 1 point what? You all agree with that? I don't need to punch it in my calculator. All right. Okay.
Yeah, 1.34.
So these are the 3 lengths. 0.27, 0.8, and 1.34. And you could keep going. I mean, if I asked for the 4 shortest pipe, like this is the, obviously this is the shortest pipe that will resonate. Second shortest pipe, third shortest pipe. Now, on the exam for this, I mean, you'll get a problem like this where you will need to know, okay, it's closed pipe, I want different lengths, so which one do I use? So you need to know how to use this equation to figure out the different lengths of pipe. Or if I give you the frequency directly, well, you can figure out the wavelength. You can use either one of these. And that will, but you need to know how to use them. And you need to know what that little n is. It's like 1, 2, 3, 4, you know. Any questions? Okay, that is all.